Welcome to the ninth chapter. The title of the chapter is Force and Laws of Motion. Today, here I'll be telling you about the different laws of motion given by Newton and what is force. First of all, this is a picture of Isaac Newton, which you all have seen somewhere, but since the chapter is basically based on this one, on Isaac Newton, so I thought to start the chapter by his photo. So let's start. Now, first thing, what is force? If we are thinking about a force, what comes to our mind at the very fast is that force is something which is either a push or a pull. Can this way? Means either a push or pull which can change the position of any substance, that is known as force. So here it is defined that force is an external effort which may move a body at rest or stop a moving body. These all are the different example of force. You see, this is a car is there which this person is pulling and trying to change its position. A ball was hit towards the goal. The goalkeeper is stopping that one, so it is changing the motion. This one, the cycling a batsman, and this one making of a chapati. These all are the application of force. Next example, what are the effects of force? So these are the effects of force which have been summarized here, and if we want to see the most precise definition of force, then force is either a push or a pull, means which can change the position of a body, then that is known as force, either a push or a pull. Now, balanced force and imbalanced force, these are the two types of forces where if the forces are acting on the same point from two different sides, then they are known as balanced force. And if two forces they cannot change the state of rest of or motion of a body, then that is known as unbalanced force. This is an example you see. This is becoming a balanced force now. When this it has changed the position, then that become a unbalanced force. This is an example of balanced force. This is an example of unbalanced force. And when one side is having two car and the other one is having single, then that is known as unbalanced force. Unbalanced force, you can see the example here. This is a seesaw. This is an example of unbalanced force. One side if the force is increasing, other side it is decreasing, that is known as an unbalanced force. Next is force of friction. And what is force of friction? And force of friction is a force which opposes the motion of an object over a surface. You can see it from this one. What happens if a ball is moving, and gradually it comes to an rest? This is due to the force of friction which is present on the surface of the earth. Similarly with the cycle and any other substance. Now, Newton's first law of motion. What does it say? It says that any body, if it is at rest, means if it is not moving, it will continue to be in its position until and unless an external force is applied on it. And from there came the definition of inertia. This is an example. A body in rest will remain at rest until and unless an external force is applied to it. And a body in motion will be in motion until and unless something is brought in contact to stop the motion. This was Newton's first law of motion. Now, inertia and mass, from here it was said that a body which is having more mass, it will have more inertia. If we can just pause the video and read all this, you can get a clear idea about this one, inertia and mass. The next is the momentum. Momentum is defined as the product of mass and velocity of a body. P is equal to m into v. The SI unit is given as kg meter per second. The Newton's second law of motion, it is said that the rate of change of momentum of any object is proportional to the applied force in the direction of force. This one. force is equal to mass into acceleration, and this was Newton's first law of motion. And this is the mathematical formulation of Newton's second law of motion, which we have already done. Since this explanation was not done to you, that's why I brought this slide. And then the Newton's third law of motion, it says that to every action there is an equal and opposite reaction, for which different examples are given. You see this one. This is a perfect example for Newton's third law of motion. The more hardly they will strike each other, the more far they will go and fall. This is an example of Newton's third law of motion. And based on Newton's third law of motion, many things are there which work. This is the firing of a bullet. This is the firing of a bullet, you see. As the bullet moves ahead, the gun it recoils, means it goes backward. So these all things so that the every action has equal and opposite reaction. Another example is if a sailor is jumping from a boat, then what happens? He is when he steps here, the boat moves backward. Then this is also an example of every action has equal and opposite reaction. Another example is the rocket. In case of rocket also, the same thing is given here. Reaction is above side, the action is in the below side. Law of conservation of momentum, what does it say? It says that at the starting of any means motion and the final after the end of any motion, if any collision is there, then the momentum at the initial stage and the final stage both will be conserved, means both will be fixed. And here one small this derivation is given for this one, for which notes has already been provided to you. So you need not to write this, or if you want, you can just pause the video and you can write this one, how this is done. So with this short explanation of the video, I just end this chapter here. Thank you for watching the video. If you have any queries, you can put in the comment section. Thank you.